Hi friends, so let us continue with our reflection and refraction of light. So the next question is, what is a virtual image and what is a real image? See, a virtual image only can be seen but cannot be captured because the virtual image usually is formed behind the mirror. Okay, so let's say you have a wall mounted flat mirror. When you see your image in the mirror, it's a virtual image because you can just see it, you cannot capture it because the image is getting formed actually in a space behind the mirror. Okay, real image can be seen and also can be captured on a paper or a screen. Okay, so that is the difference between a virtual image and real image. Real image usually is formed in front of the mirror so that it can be captured on a paper or a screen. Okay, when do we say image size is diminished or enlarged? When image size is bigger than the object size, we say that image is enlarged because the image is bigger than the object size. When the image size is smaller than the object size, then we say image is diminished because now the image size is smaller than the object size. Okay. Next question. Show 4 types of rays for concave and convex mirrors. See, whenever you draw ray diagrams for solving the problems of image formation using spherical mirrors, there are some important rays that you have to consider. Okay, those are the 4 types of important rays. So let us consider the first ray. First type of ray is the ray which is parallel to the principal axis. Okay, so for a concave mirror, if C is the center of curvature and O is the pole of the mirror, CO is the principal axis, isn't it? Now AB is a ray which is coming parallel to this principal axis. When it gets reflected from the concave mirror, it passes through the focus point. So AB, which is parallel, gets reflected, and BG is the reflected ray which goes through the F, which is the focus. So that is one important type. Okay, this is for the concave mirror. For the convex mirror, it is not converging but it is diverging. So if you shoot a ray which is parallel to the principal axis, here the principal axis is also CO. Okay, and this AB is parallel to this principal axis, right? When the ray is parallel to the principal axis, it gets reflected, but when you backtrace this reflection, it appears to be coming out of the F, which is the focus. Okay, in terms of the concave mirror, the reflected ray actually goes through the focus. Okay, in terms of convex mirror, the reflected ray will get reflected, but it will appear that it is going through the focus when you backtrace it. Okay, that is the difference. But in both the cases, parallel to the principal axis means either going through the F or appearing to go through F. That must be remembered. Okay, now second type of ray. What if instead of shooting a ray parallel to the principal axis, you shoot a ray through F? Okay, if you shoot a ray through F, it will get reflected such that the reflected ray will be parallel to the principal axis. So AB is passing through F, which means it is going through F. So its reflection, the reflected ray BG, is such that BG is parallel to the principal axis. Okay, for convex mirror, if you shoot a ray such as in the same direction as F, okay, so AB is shot such that it is, in the direction which if you extend it goes through F, it seems as though it will go through F. That ray AB will get reflected as BG, and that BG will be parallel to the principal axis. Okay, so in either case, a ray which is going through F or appearing to go through F will be reflected such that the reflected ray will be parallel to the principal axis. Okay, now let's look at the third type of ray. What if you shoot a ray which passes through center of curvature? Okay, because this is a spherical mirror and the normal is nothing but the radius, whenever you shoot a ray through the center of curvature, it gets reflected in the same line but in the opposite direction. So you shoot a ray AB such that it goes through C, which is the center of curvature. The reflected ray will go from B to A. It will be along the same line but in the opposite direction. Okay, same case in the convex mirror also. If you shoot a ray AB which appears to go through C, it will get reflected along BA but in the opposite direction. Okay, so in both cases, if you shoot a ray which goes through C or appears to go through C, the ray will get reflected along the same line but in the opposite direction. Okay, that has to be noticed. The fourth case is, suppose you shoot a ray at angle theta to the principal axis, because angle of incidence is equal to angle of reflection. If AO is the ray, okay, OG will be such that this theta and this theta will be equal, because AO is the incident ray and OG is the reflected ray. So angle of incidence COA and angle of reflection COG will be the same. So if you shoot a ray obliquely at the pole, right, at an angle theta, the reflected ray will also make an angle theta with the principal axis. Okay. Similarly for convex mirror also. See here what you're doing. You're shooting a AO ray, okay, which is at angle theta to the principal axis. The reflected ray OG is also making an angle theta. Okay, this theta and this theta are equal because angle of incidence and angle of reflection are equal. So this is the fourth type of ray. So these are the type of rays you will use to calculate image formation ray diagrams for concave and convex mirrors. Okay. Next question. Show image formation for a concave mirror. Okay. Object at infinity. This symbol which is sleeping 8 is nothing but the symbol for infinity. Okay. Infinity means very far. Okay, so if the object is very far, let's say AB is the object and it is very far, you know, and our mirror is you know, not as large, the distance from the object is very far, only the parallel rays can come to this mirror. Okay, if an object is very far from the mirror, only the parallel rays will reach the mirror, right? So what happens is, see, from A, the point A, object is AB, okay, and it is erect here because you can see the arrow mark. B is down, A is up, so it is standing straight. So it is very far, so a ray will come parallel to the principal axis, and as we know, any ray which comes parallel to the principal axis gets reflected via the focal point F. A ray from B comes, it also gets reflected and it also passes through F. So what happens is a very small image is formed at the focus. Okay, so for a concave mirror, if you place object at infinity, the image is formed at the focal point. Okay, so position of object is at infinity, position of image is at focus. Okay, and the size of image is highly diminished because see, the image of A is also getting formed at F and the image of B is also getting formed at F, so it is very small, highly diminished. Okay, type of image. See, this image, if you put a paper or if you put a screen at F, you can capture it. So it is real and it's inverted because B has gone up because of reflection and A has come down because of reflection. Okay, so it is real and inverted. Okay, so next question. Show image formation for a concave mirror where object is beyond C but it is not at infinity. Okay, it is at a finite distance. See, C is the radius of curvature, F is the focus. Object is placed such that it is beyond the radius of curvature, but this object is not at infinity. Okay, it is at a considerable distance. Okay, so we have shown the object as AB. Okay, AB is the object. Okay, so we have shown an arrow here to show that you know, the arrow is at the top of the object, which means that this object is standing straight on the principal axis. Okay, so to calculate the image, how the image is formed in this case, we have to shoot two rays. Okay, one ray we will shoot such that it is parallel, okay, to the principal axis. Okay, what happens? So as we know, whatever ray which is parallel to the you know, principal axis goes through F. So we have this line here. Okay, so let's say we call this point maybe let's say we call it G. Okay, so AG is the incident ray and GH, okay, maybe GH is the reflected ray. Okay, now let's shoot a second ray. The second ray is going to go through the center of curvature, okay, that is C. Okay, so let's call this point I. Okay, so AI is the incoming ray, and as you know, if any ray is coming through the center of curvature, it gets reflected along the same line but in the opposite direction. Okay, so this reflected ray and this reflected ray will intersect at some point. Okay, so the rays which have been shot from the point A, one parallel to the principal axis which is getting reflected here, and one through the C, center of curvature, which is getting reflected on the same line. The two reflected rays will converge at this point, will intersect at this point. Therefore, the image of A will be formed at A dash. Okay, and similarly, image of B will be formed at B dash. So you can see that A has come down and B dash has gone up. Okay, though AB is an object where A is at the top, here you can see A dash is at the bottom. Okay, so the image is inverted. Also you can see that this A dash B dash is of a smaller size than the original object AB. Okay, so when you place an object beyond C for a concave mirror, the position of the image is between C and F. Okay, here is the C, here is the F, and the image is formed between C and F. Okay, and the size is diminished because the size of A dash B dash is smaller than size of AB, which is the object. Size of the image is smaller, so it is diminished. It is real and it is inverted. Real because if you place a paper or a screen here, this image will be shown on that paper or the screen. And inverted because you can see that, you know, AB is standing upside such that the arrow is up, but A dash B dash is such that the arrow is pointing down. Okay, so this is an inverted image. Alright, let's go to next question. Show the image formation for a concave mirror when the object is at C. Okay, so AB is such that B and C coincides. So AB is placed such that the center of curvature is where the object is placed. Okay, again we consider a ray which is going parallel to the principal axis. It gets reflected and goes through the focal point. Okay, and now consider the second ray which is shot through the focal point. That will get shot and it gets reflected such that the ray is parallel to the principal axis. Okay, remember the four type of rays we have seen before. If a ray is shot parallel to the principal axis, it goes through focus, and if you shoot it through the focus, it goes parallel to the principal axis. The reflected rays will intersect at this point. Okay, and you can see that the image of A, which is A dash, is exactly below A itself. Okay, and the size is also the same, but it is inverted. Okay, so if you place an object at C for a concave mirror, the position of the image formed is also at C. Okay, and if you see the size of AB and A dash B dash, both are same. So the size of the image is equal to the object. Okay, it is a real image because you can capture this on a screen, and it is inverted because, you know, AB is arrow up but A dash B dash is arrow down, so it is inverted. Okay, so next question. Show the image formation for a concave mirror when the object is between C and F. Okay, previously it was at C. Now if we place the object between C and F, what will happen? Again consider two rays. One, you are considering parallel to the principal axis, that will get reflected and go through F. Okay, and second one, you shoot a ray such that, you know, it reflects along C itself. Okay, so any ray which is shot in the direction of the radius of the sphere gets reflected, okay, and travels along the same line in the opposite direction. So here we have a ray, first one is parallel to the principal axis, second one is along the radius of the spherical mirror. Okay, so that reflects and it reflects back along the same line, and both of these reflected rays, you know, intersect here, and the image, the object AB's image is formed here, which is A dash B dash. Okay, now you can see when you place an object between C and F, the position of his image is beyond C. Okay, so the object is between C and F, but the image is beyond C. Okay, and what is the size of image? See the size of A dash B dash. It is much larger than the object AB. Okay, so size of the image is enlarged. What is the type of image? We can capture this image on a screen, so it is a real image, and it is inverted because AB is standing such that arrow is up, and A dash B dash is formed such that arrow is pointing down. So this is an inverted image. Okay. Next question. Show the image formation for concave mirror. Object at F. See, you had at C, then you had between C and F. Now you are placing it at F. If you place exactly the object exactly at the focal point AB, okay, so AB is sort of standing up here, okay, so arrow is pointing up like this. You can take a ray which goes from A parallel to the principal axis, that you know gets reflected and passes through the F, okay. Then you can take a ray which goes along the radius of the spherical mirror, okay, which passes through C, so that gets reflected and goes in the same line, okay, but in the opposite direction. And you will notice that these two lines are parallel and they never meet. They meet only at infinity. So if you place an object F for the concave mirror, the image is formed at infinity. So position of the object is at F, position of the image is at infinity. Size of the image is very large because you know the A is formed somewhere very far and B is formed somewhere very far, so image is very large. It is a real and inverted image. Okay, the image is formed at infinity means it is formed very far away. Okay, so let's look at the other question. Next question. Show the image formation of concave mirror when the object is between F and the pole. Okay, so the pole is denoted by O here. So previously we had it at F, now we move it a little closer. So if the object is AB is kept such that it is between F and O, again you consider two rays. One ray which is going along the radius of the spherical mirror, okay, so that ray hits it and it reflects back in the same direction, okay. That is the ray along the radius you have hit it and it reflects back in the same line but in the opposite direction. So that ray, if you backtrace it, it appears to come out of somewhere here, okay. You take another ray and hit it at the pole of the mirror, it will create an angle theta. So what will happen, because of angle of incidence is equal to angle of refraction, the angle of the reflected ray will also create an angle theta. You can see my pen here. It will create an angle, the same angle reflected ray will create with the principal axis. So if you backtrace that ray also, these two reflected rays appear to come out of this point which is A dash. Okay, and note that this point is behind the mirror. Okay, so you don't have access to the area behind the mirror. Maybe it is the mirror is mounted on a wall or something. So this image is a virtual image because the reflected rays appear to come out of this point when the reflected rays are backtraced. Okay, so that is why when you place an object between F and O, where O is the pole of the mirror, the image is formed behind the mirror. And since it is behind the mirror and it is not accessible, you cannot place a screen or something, it's a virtual mirror, virtual image. Okay, and it is also erect because AB is with the arrow up and A dash B dash now is with the arrow up. Okay, so image is erect and image is enlarged because look at the size of object AB and look at the size of A dash B dash. A dash B dash is bigger than AB, so the image size is enlarged. Okay, so when you place an object between F and O, image is enlarged, it's behind the mirror, it is virtual and it is erect. Okay, now let's look at the cases for convex mirror. Okay, so in case of convex mirror, there are only two interesting cases. One is object at infinity. Because object is at infinity, you can see that we have only parallel rays coming in. A ray parallel to the principal axis comes, so it gets reflected such that it appears as though it is emerging from F. Similarly, B comes, B is parallel and gets reflected such that it appears to be coming from F. And you can see that the image is formed therefore at F, and it's a highly diminished image. Correct? So if the position of object is at infinity for a convex mirror, the position of the image is at F behind the mirror. Okay, this is convex mirror, so this outer surface is reflective. The back of the mirror is not reflective, it is solid. Okay, size of the image is highly diminished, and the type of the image, since it's behind the mirror, you cannot capture it on a screen, so it is virtual and it is erect. Okay, so this is the case for the convex mirror with object at infinity. But what if I have an object which is not at infinity? Okay, it is at it's at a distance which is measurable. Okay, it is not very far, it is okay, it is let's say 10 centimeter or 20 centimeter, something from the pole of the mirror. Then what happens is you can shoot two rays. One ray will be parallel to principal axis, and that will get reflected because this is a convex mirror. It will get reflected, and it will get reflected such that it appears to be coming out of F. Okay, because F is behind the mirror, because this is a convex mirror. Okay, F and C both are behind the mirror. Okay, note that. And if you shoot another ray which is along the direction of the radius, which is C, which passes through C, then that ray will get reflected back on the same line but in the opposite direction. Okay, so these two reflected rays, one appearing to come through F and one appearing to come through C, they both intersect behind the mirror at A dash. Okay, so the image of A is formed at A dash, and the image formed of AB is A dash B dash. So if you place an object not very far but at some distance for a convex mirror, the image formed is between the pole and the focus, O and F. It is diminished because you can see the size of the image is smaller than the size of object, and the type of image, it's virtual because it's behind the mirror, you cannot capture it, and it is erect. Thank you.